I'm Christiane Barth, professor for mathematics for business and economics here at the University of Zurich in Switzerland. My work usually is about mathematical modeling and optimization, so pretty far from Eurovision. But I've been a huge Eurovision fan ever since Nicole won for Germany in 1982. I even learned how to play the guitar because of her as a kid. During a low point of my PhD, when everything felt a lot too serious and too abstract, I made myself a promise. If I ever make it to full professor, I will do a project on my one true passion, Eurovision. The only problem was I'm a terrible singer and my guitar playing is not a lot better either. So how could I contribute to Eurovision with my skill set as an industrial engineer? The answer came years later when Denise Saure, a co-author of mine from Chile, and I were watching Eurovision, debating how we could use mathematical modeling to make the allocation of countries to semifinals fairer. Finally, my true passion, Eurovision, meets my professional work.
Hi, this is Jie, a PhD student at University of Zurich. I grew up in China, finished my bachelor there, then came to Switzerland for my master's study, and now it's my PhD. As a person who loves sports and all lively events, I found Eurovision very fascinating, not only academically, but also culturally. That's why when I first heard about this research idea from my professor Christiane Barth, I was immediately drawn to it. It is engaging, data-driven, has real-life relevance, not only for Eurovision, but for any systems where voting and fairness matter.
So let's set the stage. As we all know, only the big five, Germany, France, Spain, Italy, and the UK, as well as the host country, advance straight to the grand final. All the other countries have to go through one of two semifinals. And here's the catch. Only countries within the same semifinal can vote for each other. So if you're in the same semifinal as your friends, countries that historically voted for you, you have an advantage compared to when you're separated from them.
To reduce these effects, the European Broadcasting Union introduced a poll system. Each year, countries with strong voting ties like Greece and Cyprus are placed in the same pot, split into two semifinals. It's like the Eurovision's version of separating two besties during the exam. The idea is to distribute block voting countries evenly.
But while the pot system is well-intentioned, we were wondering, does it actually work? What is the outcome? Are the outcomes as fair as they're intended to be?
That's where I started digging into data. Let's start a classic, Greece and Cyprus. Since the introduction of the semifinals, they were in the same semifinal 7 times. The last time in 2023. In each of those 7 times, they gave each other top points. A true love story. Well, from a Swiss perspective, this may seem less romantic, because Greece and Cyprus can counter each other, while Switzerland has never experienced such a strong televoting love. But voting block is not the only bias we found. Another one, running order. Specifically, performing the last or the first in the semifinal. Countries performing the last can expect to receive points from 88% of the other countries in the same semifinal. Then you may think, okay, maybe strong songs are placed in the end on purpose. But even when we control this using betting odds, performing later can still get more points than expected in the semifinal.
So we identified two key sources of bias. Number one, who is in your semifinal? And number two, when do you perform? For us, it wasn't enough to just identify this problem. We actually wanted to fix it. So how do we make it fairer? Our idea was to minimize something we call the bias gap. That is the difference between the largest total bias that is incurred by a country that has maybe a lot of their friends in the same semifinal or runs in a really good starting position, and the smallest total bias, which is incurred by a country that maybe has no friends within the same semifinal or is in a bad starting position. How do we minimize this bias gap? We formulated a mathematical model, a so-called mixed integer optimization problem. That sounds complicated, but trust us, we don't have a lot of knowledge about music, but we know how to use this math.
We can estimate how much help each country gets from the semifinal, both from their allies or from their running orders. Then we fed this data into the model. The algorithm will return two balanced semifinals and even suggest a running order to level the playing field. For instance, if a country doesn't have many natural supporters in the semifinal, then the algorithm will place it later in the show to boost the visibility.
In short, we try to build a Eurovision fairness machine. It does not compose songs, but it tries to allocate countries to semifinals to ensure a balanced contest. We know that our mathematical fairness model might seem like a black box to many, that just spits out an allocation to two semifinals and a running order. So we don't expect it to be applied in Eurovision anytime soon. There's a reason why the show is designed by artistic directors and producers.
Well, obviously, we did not model the effect from crazy costumes, fireworks, or fog machines.
And trust me, we should not be in charge of optimizing everything around Eurovision using our math models.
Confirmed. Leave the music to the professionals.
We just hope that our work brings a new perspective to the conversation on Eurovision with a little bit of math and a lot of love for the contest.
And we are looking forward to see you at the conference.
See you soon.